Hi there, and welcome to Influence, a program by the College of Agriculture and Life Sciences. I'm your host today, Jessica Graves. Today we're here with two of our faculty members from the Agricultural and Biomedical Engineering Department. Dr. Lowe, why don't you introduce yourself first? Tell us a little bit about your academic history, where you're from. Tell us who you are.
Hey, all right, thanks, Jessica. So I'm Wes Lowe. I am a graduate, actually, of our Agricultural Engineering Technology and Business program for my bachelor's. I'm originally from Houston, Mississippi. I grew up in that rural area. Recognized early on that I had a passion for ag, and just felt like came to Mississippi State and felt like that our AETB program was a great fit for me. Plugged in, and obviously there was, as we've talked about, there's some hiccups along the way, but finished a bachelor's and then rolled right into a master's, and then got the opportunity to do a PhD and came on in the role of a professor, and have really enjoyed it. So excited about the opportunity and to be able to get in and plug in with our research program and also engage with our students.
Yeah, awesome. Those are all very important things for us. Dr. Chesser, why don't you tell us who you are, where you're from, what your interest is?
Yeah, thanks, Jessica. So very much similar story as Dr. Lowe. Actually from Starkville, born and raised right here, born a Bulldog, and so started working actually on the South Farm in high school, which really piqued my interest in agriculture and production agriculture from the animal side as well as the row crop side. I'm a product of the AETB program, proud product of that program. Started working full-time for the university as a research technician and worked my way through a master's program and a PhD program. Started in 2018 as an assistant professor in our department. So I teach and advise students in our Ag Engineering Technology and Business program. My research background is on the ag machinery, ag technology development, as well as poultry housing systems, confined animal production, so on the engineering side of that, controlled environments, heating, lighting, ventilation, things like that. So
awesome.
Yeah.
Awesome. Dr. Lowe, and I understand that you come from an agricultural background, and perhaps that's kind of what shaped some of your interests, maybe your research interests. Could you talk a little bit about that?
Absolutely. So just to understand ag production systems and understanding the importance of those and the impact that they have on our state really helps me to identify areas in which we can make improvements to what we're doing. It's so important, especially with the limited resources that we have, that we be efficient in what we do. And I think one of the big things that gets lost sometimes in research is the end product, the results, the impact for our growers. A lot of times we get caught up in answering questions, but it's more important for me to identify, are we asking the right questions? And from that, developing not only just answers, but also solutions that have a positive impact to our producers' bottom line.
I absolutely love that, and I'm a production person as well, and so it's always fun to really understand and see how faculty make that connection and truly understand that the end goal is our stakeholders oftentimes, and finding ways that we can be innovative and have a lot of discovery happen, but also that is very applicable to technology in this particular instance that can be used on the farm and to help farmers and ranchers improve their outputs and perhaps maybe sustainability. We talk a lot about sustainability these days. I know we're going to talk a little bit about that as well. So you both have very different kind of backgrounds and maybe specific research interests, but I understand also that you work very closely together. So Dr. Chesser, why don't you talk about initially how you kind of complement each other as two faculty in a single department in how you conduct research?
Yeah, so my skill set really deals with production and design of technology, of machinery and ag systems from a construction standpoint, from a fabrication standpoint, from a machining standpoint, from from an AutoCAD standpoint, from taking creating a part, an assembly digitally, and then manufacturing that part. And so from a design standpoint, that's kind of where I come from. I have a skill set in machining and welding and fabrication. And I think that's where we complement each other a lot. We do a lot of ag systems, applied engineering, machinery, instrumentation, implements, in production agriculture on the row crop side, as well as some in the animal side. So I think that's kind of my background and how Dr. Lowe and I complement each other. And he can speak to sort of the instrumentation electronic side a little bit more.
Absolutely. So, Daniel does an awesome job of putting together a really solid, robust system. When we have a project, he's incredible at figuring out mechanically how this thing should work, and then we try to figure out ways that we can either instrument it to capture data, or more specifically, a lot of times here as of late, we've started delving into the automation/autonomy space. Taking some of the human factor out of the mistakes, I guess rather, out of the operation of equipment. So we come up with new and innovative ways to make these systems function to be more efficient. So I do a lot of instrumentation, automation, electrical and electronic control, and fitting those together with what he's designed and built. I think really ends up being the space in which that I feel like that I bring the most to the table in what we do.
Yeah. So let's talk a little bit more about this autonomous space. Most of our viewers will understand what a drone is, right?
Yeah.
And so we talk about this automated and autonomous type of technology, and I understand that you guys have been working on a really cool project lately with an autonomous boat, right?
Yeah.
And so I want to hear more about this, and tell me a little bit about the boat and how it functions, and then we'll talk a little bit more and delve into the application piece of that and what you're going to do with it. Dr. Chester, you want to tell me a little bit about this boat?
Sure, I will. So, in the autonomy in the drone space, we typically think of an aerial drone, but applications in water, how do we use that drone technology to capture information from the water? So we actually have a really cool project that we've been working on. We acquired an autonomous boat. It's an autonomous surface vehicle from a manufacturer in Massachusetts called Sea-Track. And we've been doing some performance testing. The boat is solar powered, so it makes its own power. It's all electric. It's about the size of a 14-foot John boat is about the footprint of the boat. It's fiberglass construction. So the boat is designed to withstand heavy sea states, so we can send the boat out, we can program a mission, set a series of waypoints for the boat to navigate in. We can send the boat out for weeks or months at a time, in the Mississippi Sound or the Mississippi River or some of our inland waterways. It also has a suite of sensors on the boat. The boat is kind of a sensor agnostic design, meaning that we can add or integrate or incorporate many different types of sensors that would sense things, characteristics of the water, like temperature, turbidity, salinity, organic matter. So we can really send the boat out. It has a real-time communication system, so it's satellite communication, cell communication. So as it gathers data from the water, it sends that data back to a cloud-based server. And really what we're trying to look at is the land-water interaction. What's going on there? How does what we do on the land affect what happens in the water with our aquatic ecosystems, on the Gulf Coast with our oyster beds and our shrimp production? So how does what we do on land affect those things? And then from that information, one of the good things is that we can bring that back and develop best management practices to better manage our natural resources.
Yeah, that's so amazing. And talk about rich data collection and the amount of real-time data that you're able to capture through that. That's so interesting. Dr. Lowe, I understand there's a little bit more that we can do with this, maybe perhaps for our aquaculture producers. So talk a little bit about maybe what the future holds and how this piece of technology may be used in aquaculture systems.
Yeah, absolutely. So, one of the things is with aquaculture is we're typically dealing with a closed environment. So it's important that we stay ahead of recognition in any type of negative parameter that may be happening in that water quality area. Currently, though, we're really I won't say a little bit behind, but we're not capturing as much data as we probably should. There's tons of things that, especially in our catfish production systems, that negatively affect production. Blue-green algae being one of those, and then also dissolved oxygen. And so understanding that environment that these fish are in and understanding how those parameters affect us in terms of profitability is extremely important. However, up until this point, we didn't have a platform in which we could capture that data in real time. We were taking water samples, carrying them to the lab and analyze. And what we hope to do with this vessel is actually put it in catfish ponds and look at in real time what's going on out there.
Sure.
So what does that oxygen profile look like? So currently we take 1 point or a couple of points at best of dissolved oxygen in the water. What we'd like to see is, can we map that oxygen profile? Is it consistent across the entire pond, or does it vary? Is the point in which we're taking that water sample for a dissolved oxygen to determine when to turn on our aerators in the evening, for instance? Is that appropriate? And then secondly, and I mentioned before, the blue-green algae deal. So that causes off flavor in fish. So typically we catch a fish and carry it to the processor, and they check it to see if it's on flavor. Yeah. We're hoping that we can, with this vessel, we can take it and incorporate that with aerial drone technology to basically create an algorithm or a model that we can use to analyze some type of aerial spatial data of the pond to identify when we start to have blue-green algae blooms.
Yeah.
Therefore, we can start our treatments for those earlier and prevent that off flavor that prevents the grower from selling that fish in a reasonable amount of time. Instead of having to feed them out a couple of weeks and change up some feeding characteristics and maybe extra treatment of the water, we can go ahead and preempt some of that.
Yeah. Well, we are almost out of time, and I am so grateful for the time that you spent with us this morning. We've all learned a little bit more about autonomous technology in this space. So that's going to do it for us for our Influence Show. We'll see you next time on Influence.